Hello, my name is Neena Sathi and I represent Applied AI Institute. Our institution is dedicated to developing innovative solutions and educational materials leveraging AI and generative AI technologies. In this video, we will introduce you to Retrieval Augmented Generation or RAG, which augments LLM to remove some of their limitations, specifically as it relates to outdated or incomplete or private contents. A large language model or LLM is a type of AI model that has been trained on large quantities of unlabeled text under self supervised learning and can perform a variety of natural language processing or NLP tasks. The text data may range from books, articles, information is stored on public internet such as Wikipedia, social media posts, and online conversations. The architecture of an LLM consists of layers of neural network that learn to generate language in a way that is similar to how humans use language. NLP tasks include classifying text, writing summaries, and answering questions in a conversational manner. A key problem with these LLM is that they are trained once and then used many times. The training takes a long time and it is economically and technically not feasible to train the model on the latest corpus before every user query. As a result, there are several limitations with the LLM. First, hallucination. In the context of AI models, hallucination refers to when AI model generates false or nonsensical information unrelated to the input data or reality, often due to limitations in its training or design. Second, organization specific terms. Every organization has specific terms that it uses to represent its organizational knowledge. Public LLM corpus does not include these terms that are unique to a specific organization or field. These terms are often introduced using training data. Third, dated corpus. The training takes a long time and it is economically and technically not feasible to train the model on the latest corpus before every user query. LLM carry a dated corpus. Additionally, the LLMs carry a representative set of public information, which means it is not likely to have all the information you may be seeking in a query. In this video, we will cover how will you supplement an LLM with latest, incomplete, or private contents. So, how do we address these things? To put this into a context, consider the popularity of the Harry Potter series. Imagine the convenience of a chatbot that could discuss these books in detail, especially for those who might find reading the extensive volumes challenging. Like my late mother who loved the series, such a chatbot could answer any questions about the series if it were fed all the relevant information, including detailed summaries or character analysis from all the books. In our coursework, we have included an active learning project using Harry Potter books. This chatbot could answer any questions about Harry Potter's friend or other details, which would be particularly useful in setting like trivia quizzes such as those my grandchildren and I encountered at a Harry Potter exhibition during our latest visit to London. I can address those issues because our large language model is already customized to include all Harry Potter information available to us. This brings us to the concept of RAG, or retrieval augmented generation. RAG is a technique used to enhance the accuracy of your LLM by integrating a wealth of information from the latest sources, external databases, or even your own proprietary data. For example, several individuals have approached me with a desire to write their autobiographies using their own content. They wonder how they can compile it effectively. Fortunately, ChatGPT and other large language models can assist in organizing and composing a comprehensive autobiography by leveraging the RAG technique. The necessity for RAG arises because the LLM is trained only up to the most recent comprehensive dataset available, which in our case includes public internet data up to Q1 of 2023. It doesn't inherently include private or company specific information and may lack data on recent events or niche topics. Consequently, while the model has extensive language knowledge and can classify information into relevant categories, it may not always align with the specific needs or priorities of every user. So, when you interact with a public LLM, you might question its understanding or its knowledge base concerning new or specific information. Although it is well informed with public data, it may not reflect the most current events or include personalized data without additional inputs. To address these gaps, you can use RAG to input private or recently relevant information, ensuring that the model prioritizes and synthesizes this data according to your needs. By providing a classification table or specific prompts, you can guide the LLM to better align with your information priorities, making it a more powerful tool for personalized responses. To update our large language model with the most current information, consider the example of movies. Suppose the LLM's knowledge is based on data that predates the 2023 Oscars. To make it relevant to current movie discussion, I would need to augment the model with the latest data, such as the 2023 Oscar winners, my personal watch list, or the latest movie reviews or movie ratings. This process involves integrating new and specific information into the existing model to ensure it remains up to date and reflective of the latest trends and insight in the cinema. Let's look at an example to illustrate the importance of embedding. For instance, we know that GPT's knowledge does not include information from 2022 to 2023. If someone were to ask a question like, I would like to see a movie that won the Oscar for original screenplay in 2023, GPT would politely inform the user that its knowledge cutoff is September 2021. As a result, GPT cannot provide information on Oscar winners for Best Screenplay in 2023 and would suggest searching the internet for the most up to date information. In such cases, embedding can be utilized to supplement the model with additional knowledge, enabling it to provide relevant and current answers to users' inquiries. So, if we have to collect a series of PDF documents which contains the latest information, how will I supplement an LLM with these latest documents? There are several alternatives, and we'll cover all these alternatives one by one. So if we have a collection of PDF documents, these can be utilized to enhance the responses generated by a public large language model. This is a core concept behind techniques like retrieval augmented generation, which allows the integration of external data sources into the model response process. One common method is to include pertinent content within your query, where you feed the entire content of a document into the LLM and let it process the information to prepare its response. While straightforward, this approach can be resource intensive depending on the volume of documents you plan to analyze. Alternative 2, we could achieve this by incorporating information in a prompt. For example, suppose we have an article containing information about the Oscar winning screenplays from 2022 and 2023, which we found on the Oscar websites. If we ask a question like, I would like to see a movie that won the Oscar for Best Adapted Screenplay in 2022, and also inquire why is it called an adapted screenplay, a question not addressed in the article but within GPT's original knowledge base. Embedding can help us combine the two sources of information. The resulting output would include both the information we provided, such as the best adapted screenplay in 2022 being Coda, and the explanation of what an adapted screenplay is, which is not present in the article but can be found in GPT's existing knowledge base. For simplicity of explaining, we added screenplay winners for 2022 and 2023 in the prompt. Practically speaking, we may need to add all Oscar wins in 2022 and 2023 in each prompt. It may be cost prohibitive to use such prompts, especially if we are dealing with large body of information, and often we may be above the prompt word limit. The second method for enhancing a large language model with external data is called simple search. In this approach, you select a subset of the document using specific tags or keywords. The selected passages are included with the question. For instance, if a user is seeking information about the best screenplay winner at the 2023 Oscars, you could use keywords such as screenplay, Oscar award, and 2023 to search within the document. This will result in a subset of the document that is provided to the LLM along with the question. Lucene Search leverages an elastic database to effectively organize and retrieve information from vast documents. By tagging passages and searching within these tags, user can swiftly pinpoint the needed data. The process becomes more refined over time as tags are revised based on feedback. This method is cost effective for searching through large documents, although the precision of results hinges on the quality of the tagging system implemented. Microsoft Copilot is a good example of this approach. Copilot effectively searches across the internet and provides a generative response to the query, along with information on sources it used. Which movie received the Oscar for Best Movie in 2024? Was it a new or established cast? Copilot assembled and extract information from 6 sources to generate an overall response. Alternative 4 involves RAG using embedding with vector databases. The concept of embedding is a crucial element in the functionality of large language model. And you might wonder how an LLM knows where to look for information. Embedding is the process used to create a searchable corpus, and it is also the technique we employ to categorize our private or most recent document. We will utilize computer vision to dissect documents into more manageable pages and paragraphs. This technique is not just about breaking down the text, it is about understanding the structure of the document at a granular level. Once we have our document segmented, we will employ embedding to transform each chunk into a vector. Think of this as translating the text into a language that computers can understand more deeply, a numeric representation that encapsulates the essence of the word on the page. The next step in our journey is a semantic search based on similarity. By using these vectors, we can find connections between different pieces of text that go beyond just keyword matching. We are matching based on the context and the underlying meaning, which is a game changer for retrieving accurate information. Furthermore, semantic search isn't just about spotting similar phrases, it's about understanding content and meaning. This depth of search allows for more nuanced and relevant results because it understands the text in the way a human might. This approach cost a fraction of alternative one, where we fed the entire document. Alternative 2 and 3, which use cheaper searcher techniques, are less expensive but also less effective in performing semantic search. So, we have discussed four methods so far. The first method involves inputting the entire content of a document into the LLM. While straightforward, the main drawback is the token limit, which means larger documents might not be fully processed due to the model's capacity constraint. The second method is the simple search, an affordable option for large documents. However, the effectiveness of the search is contingent on the keywords or tags you provide. The third method is the Lucene search, which is gaining popularity in topics like GitHub Pilot or GitHub Copilot. It is based on using an elastic database for text searches. Finally, we have embedding with a vector database. Today, we will focus on how we can leverage this embedding and vector database to accurately retrieve responses tailored to your specific documents. Thank you for joining me today. For more information, feel free to connect with us at nsathi@aaii.ai. We look forward to further interactions and sharing more about our AI and generative AI offerings in the future.